Hospital-acquired infections are now recognized as a major cause of unnecessary sickness and pain, lengthened hospital stays and disabilities, post-operative complications and death, incalculable financial loss, and superbug evolution.
A significant, a worryingly high number of patients develop hospital-acquired infection.
Healthcare infections have been a major problem in modern medical practice.
Patients continue to get infections, and anything we can do to reduce those infections has to be good news for the patients, for the NHS, because infections are a cost, and also for antibiotic stewardship, because the fewer infections there are, the less we have to use antibiotics and the less pressure we put upon them.
The type of bacterial infections are changing and they're getting more resistant to antibiotics. So the predictions from an official report in the UK said that it's going to be an enormous problem by 2050. It will cost trillions of pounds to the worldwide economy and in millions of deaths.
Reducing hospital-acquired infections have been the motivation behind the groundbreaking technology used in antimicrobial gloves.
The problem we're trying to solve with this product is to help reduce hospital-acquired infections and cross-contamination within a healthcare environment. So we target high-risk medical devices in order to use our technology to help try and reduce these infections.
The antimicrobial glove is a game-changing healthcare innovation that helps to prevent contamination and transmission of pathogens in healthcare settings. During the manufacturing process, the patented antimicrobial is bound to the outer surface of the glove. The glove is the first to contain a non-leaching antimicrobial technology, with its pathogen-killing molecule providing active protection, designed to help prevent the spread of infectious diseases. Microbes are most frequently transferred in hospital via the hands of healthcare workers, which have become contaminated through contact with infected patients or contaminated surfaces. The active ingredient on the glove is a photosensitizer, which generates singlet oxygen when exposed to light. This singlet oxygen oxidizes the bacteria's protein and lipid, thus leading to the death of microbes that get transferred to a glove. The activated oxygen is short-lived, but it is generated continuously, never exhausted, and rapidly kills bacteria. The innovative technology is effective in killing different types of bacteria, including MRSA and Enterococcus faecalis. This unprecedented innovation is able to reduce the spread of infection and cross-contamination in hospitals, thus revolutionizing an aspect of medical care that has previously been overlooked.
I'd describe the product as efficient because it uses light and air to make biocides. I'd describe it as environmentally friendly because it doesn't release any biocidal materials or toxic materials to the environment. And I'd describe it as easy to use. It's a very easy to use product. You use it just like a normal glove. There are no additional requirements for it.
The way that the product works is entirely different from conventional infection control agents. And the success of that kind of product against resistant bacteria is particularly interesting.
We were approached to see if they were acceptable to the staff and then to test them both in the laboratory and eventually on the ward. We've been doing this now for a couple of months. We've completed a usability study where we've shown the gloves to members of staff. They've tried using them and really they found them identical to their existing gloves.
We were approached to actually look at the kill of the bacterial product using a microscopy. So we use our microscopes to visualise that kill in real time. I'm very proud of what we achieved. Myself and Robert, when you first brought this question to us, it seemed initially to be a relatively straightforward thing to do. But in the end, it was quite a challenge to actually get this products to be visualised on the microscope. It's not an easy thing to do. And actually, finally when we got it to work, it was fabulous to see that 100% kill under the microscope was just brilliant. And we were very excited when we finally got the results.
Innovation is our DNA. Since inception 30 years ago, we continue to reinvent ourselves in the product that we offer and also the way we do things at Hartleger. We chose chemical intelligence as our partner for many reasons. And I guess the main reason is the passion for innovation that both of us have in common. The antimicrobial technology is designed as such where it is easily added into the existing glove production process, making the product very affordable and accessible to the market. And we believe that the product will be widely used and it will be a new standard of glove.
I hope that the product will be adopted by health services across Europe and indeed across the world. I think it's completely different from anything that's already out there.
It's certainly innovative, it's certainly extremely interesting. We've seen evidence that they kill bacteria.
This technology is leading the world.
We would like the legacy of this product to change the landscape of this industry.
Potentially, it could be globally used, so watch this space.
Hartleger's expertise, commitment and financial support have proven absolutely decisive. In particular, Mr. Kwan's desire for reducing infections worldwide with the influence of the antimicrobial glove has underpinned the team and the ethos adopted by the team and has now resulted in another world-first innovation for Hartleger.